All right, let's set the scene. Imagine you're standing in front of a reefer unit. It's in heat mode, the icon is lit up, controller's calling for heat, everything seems fine.
But it's not. You check the temperature differential and it's actually dropping. The unit is cooling.
Which makes no sense. It's a physical contradiction.
Yeah.
And that's exactly what triggers alarm code 22, the heating cycle check.
Right. The unit's logic board is doing its job. It's sending voltage to the heat solenoid, but the sensors, the return and supply sensors, are telling it a different story. They're showing a temperature drop across the coil.
And since thermodynamics says you can't have both, the controller flags it. It assumes a component has failed.
Exactly. And for this deep dive, we're pulling directly from the technical service manuals and diagnostic procedures. The documentation is really clear on this.
It classifies code 22 as a prevent alarm. It's essentially a warning shot from the system.
A warning shot, yeah. But if you ignore it, the logic escalates things very quickly. It goes straight to alarm code 24, which is a heating cycle fault.
And that's where the unit actually starts taking action against itself to protect the cargo.
It's aggressive, especially in the fresh set point range. A second time you get that cooling while heating condition, it just triggers a full shutdown. It won't risk freezing the load.
Frozen mode is a little different, though. It might just lock out the heat operation. But there's a setting that catches a lot of technicians off guard, the restart setting.
Oh, yeah. If restarts are disabled in the guardrail settings, you don't get that second chance, that warning.
None at all.
None. Code 24 becomes a shutdown alarm on the very first occurrence. So, depending on how a fleet manager configured that unit, one little glitch could stop the engine cold.
Okay, so with stakes that high, you can't just guess. You can't just start swapping valves and hoping for the best. You need proof.
And the manual is explicit here. You start with the digital evidence, hook up a laptop, use WinTrack, and download the ServiceWatch data logger.
And you have to look at the technician user level specifically.
Yes, that's key. You need to see the system conditions at the exact moment the alarm was set and when it was cleared. It tells you if you're chasing a hard mechanical failure or maybe just some sensor drift.
And speaking of sensors, checking the sensor grades is more than just ticking a box on your checklist.
It's critical math. Different grades have different resistance curves. If the controller thinks it's reading a grade 1 sensor but a grade 2 was installed, the whole temperature calculation is off.
So it might think there's a temperature drop when the air is actually heating, and then it throws the alarm falsely.
Precisely. So once you've cleared the sensors and you've verified refrigerant levels are good, then you have to look at the most overlooked variable. It's not even a component on the unit itself.
Airflow.
Airflow. This is where the mechanical problem usually turns out to be a loading problem.
It's that classic short cycling scenario, isn't it?
It is. You find a pallet jammed right up against the return air bulkhead. So the discharge air comes out, hits the cargo, and bounces straight back into the return. It never circulates through the trailer.
And that tight little loop just completely confuses the sensors.
It does. The return air temperature drops fast because it's just recycling the same cold air, creating a cooling differential even when the heat is on. The unit thinks it's failing, but really it's just choking.
So only after you've verified the airflow is clear and the sensors are accurate, only then do you start looking at the actual hardware.
Right. Then you check the plumbing. You need to verify the refrigeration valves are actually moving.
And you can't just listen for a click.
No, you have to force them. The manual says to use the interface board test mode. You physically command the valve to open or close, and you watch the gauges to confirm the refrigerant flow actually changes direction.
It's a real stress test for the hardware. So to sum it up, code 22 is the unit saying, hey, there's a contradiction here. I'm calling for heat, but I'm sensing cooling. It gives you a window to fix it.
A window before code 24 steps in and shuts down the whole load. It's the unit asking for help before it has a total failure.
And that brings us to our final takeaway. We often rush to replace a solenoid or a sensor when we see a cycle fault. But with code 22, you really have to ask yourself a different question. How often is the component failure actually just a forklift driver who stacked the pallets too close to the bulkhead?
The fix isn't always a wrench. Sometimes it's a quick lesson in proper airflow.